So this video is for 2-6 to 2-11 homework for those who maybe have some questions on any of these. So our goal is to state whether or not these triangles are congruent. And the reasons we're going to say if they are is side, angle, side, 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 angle, angle, side, angle, side, angle, hypotenuse leg. Those are the reasons. Okay. So let's take a look at these. So for this first one, AC is a straight a segment, which means this is also going to be 90 degrees. Okay. Because it is a straight segment. So together they have to add to 180. We also have that this angle here is the same as this angle here. And then we have that this line right here, they both share. Okay. And that's by the reflexive property. So looking at this, I have, and just because it's a right triangle does not mean it's hypotenuse leg, because I have just a leg, I don't have the hypotenuse. This is actually going to be angle, side, angle. That's the reason. And let's say I say triangle A, D, B. And so A corresponds with C, D corresponds with D, and B corresponds with B. On letter B. Okay, so this AC is the same as this side over here, BD. I know that they both share this side. These sides are the same. That is reflexive. So I've got two sides being the same. And then I have this angle here at B and this angle here at C. So these two triangles are going to be congruent by side, angle, side. And let's say I call, let's say I start with the bottom one. Let's just call that one ABC. If I call this one ABC, A corresponds with D. B corresponds with, so let me just kind of match things up. I have to be careful because C in this triangle, sorry, B in this triangle is in between the blank side and the orange side. So that's going to correspond with this. So we have to kind of be careful. So this is going to be D, C, and then what corresponds with C in the triangle ABC, since it has the pink mark, is going to be B. So you got to be careful. The same letters don't necessarily go in the same spot. Depends on the situation. On letter C, okay, I've got this side here, which is 6, this side here, which is 6. I have that 4, but I don't know anything on the other side, so that's not going to be helpful to me. I do have vertical angles, so those two angles are going to be the same. I also have parallel lines, so I've got this line and this line that are parallel. And let's say I have a transversal. So let's call this our transversal. So that means that this angle here is going to be the same as this angle here because of alternate interior angles. Okay, so let me just clean up some of that. Let's see what we have left. So I have an angle, and a side. Okay, in this triangle, I have an angle, angle, side. So this would be angle, angle, side. In this one, though, I've got side, angle, sorry, angle, side, angle. So they're not in the same spot. So this is not enough information. The 6s are not in the same spot. in relationship to the blue angle. Okay, on D. So if I'm looking at this triangle here, that's in red, and this triangle here, that's in purple, right now you'll notice that I'm drawing over that red line. Okay, so right now they both share that side because of reflexive property. Okay. And then if I'm looking at this, I have this double mark here in my purple one and this double mark here. So those two angles are the same. I have the single angle at A and the single angle at B. So if I'm looking at, let me just kind of color in this purple one for a second. If I'm looking at the purple one, I have this angle, this side, and this angle. So that's actually going to be not angle, side, angle. It's actually going to be angle, angle, side. Okay, this angle, this side, and then I'm skipping over this angle. I don't know this angle. So it's really going to be angle, angle, side. And then if I'm looking at the red triangle, I also have angle, angle, side. So this is going to be congruent. Angle, angle, side. And let's say that triangle ABC, which is my purple one, A is going to go with B in the other triangle. B, okay, so in the, so let me just double check here. Okay, so in my purple one, I've got this angle here at A, and that's going to correspond with this angle here at B. And then my B in my purple one is actually this angle here, okay, which is going to correspond to this angle here, which is at A. And then D is going to correspond with C. On E, so let me just kind of color code. So I've got this purple triangle here. And let's say I have this green triangle here. Okay, so in the purple triangle, I have this angle here, and I also have that in this triangle here. So we got those two angles. I've got this angle and this angle. And I have this angle and this angle. Now that's angle, 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 which is not going to be congruent. So not enough info. Angle, angle, angle is similar, not necessarily congruent. On F. So let's see, I've got this 31 with this 31. I've got this 40 with this 40. And I have this 42 with this 42. So these are going to be congruent because of side, side, side. And let's say I call it triangle. Let's say I say RQS. So R is right here where I have the purple and the blue. So that's going to be over here. That's going to be my K. And Q is where I have my purple and my orange. So that's going to be over here. That's going to be G. And then H. Okay, on 22-7, when the shapes are reflected across the line of reflection, the original shape in the image create a new shape. For each reflection below, name the new shape that is created. So if I am drawing this in and I was to reflect it, this is going to end up giving us a heart. In this one, if I have this, I'm actually going to get a square because this is going to be 3. This is going to be 3, which means it's 6 across, and this is a 6. So this is going to be a square. On C, it's basically looks like an isosceles trapezoid. And so if I reflect that across that line, what is going to happen is I'm going to get a regular hexagon. Okay, on 2-8, plot the following points, and connect them in order given. Then connect points A to D. So -3, 1, 2, 3, 1, 2, 3, 4. That's going to be A. 1, 6, 1, 2, 3, 4, 5, 6. That's going to be B. 5, -2, 1, 2, 3, 4, 5, -2. That's going to be C. And 1, -4, 1, 2, 3, 4. That is going to be D. And then if I connect the lines, oops, cut it in triangles. Connect the line A to B, B to C, C to D, and D to A. They want us to decide what this shape is. It says a rectangle is a 4-sided polygon with 4 right angles. Does the shape you graphed appear to be a rectangle? Use slope to justify your answer. So they want us to find slope. So I'm going to find the slope of this. Let me do it here. Draw it up. Here. So when I'm doing that, that's going to be a 2 and 1, 2, 3, 4. So for AB, that slope is going to be 2/4 or 1/2. Okay, here, BC, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. So for BC, it's going to be a -8/4, because it's always change of y over change of x, which is a -2. So these two here are negative reciprocals, which means 90 degrees. So that means it's perpendicular. So those are 90 degrees. And then let's see if I do CD. So this is going to be 2 and 1, 2, 3, 4. So CD, M is going to be 2/4 or 1/2. And then let's double check this last one. So it's going to be 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8. So AD is going to have -8/4, which is a -2. So again, these are also going to be negative reciprocals, abbreviating, sorry, which means perpendicular, which means 90 degrees. Okay, so it is going to be a rectangle. If quadrilateral ABCD is rotated 90 degrees about the origin, what are the coordinates of the vertices? Okay, so this is A, this is B, this is C, this is D. And we're going to rotate it clockwise 90 degrees. So I'm going to be going like this 90 degrees. Okay, so I'm going to come up here to the top menu. I'm going to rotate it. Okay, and then I'm going to jot down these points for myself. Okay, so I'm going to jot down that A prime is at 1, 2, 3, 4, 1, 2, 3 at 4, 3. B prime is at 1, 2, 3, 4, 5, 6, -1. C prime is at 1, 2, -2, 1, 2, 3, 4, 5, -2, -5. And D prime is going to be at -1, 2, 3, 4, -1, -4, -1. And let me rotate it back. Okay. So if I want to find the coordinates of it, A prime is now at 4, 3. B prime is now at 6, -1. C prime is now at -2, -5. And D prime is now at -4, -1. At -4, -1. Okay. Determine the area and the perimeter of this trapezoid. So first off, there is a formula for area of a trapezoid. You can take base 1 plus base 2, top base plus bottom base, times it by the height divided by 2. So when I'm saying base 1, let's say this is our base 1, which is 5, plus, let's say my base 2, which is this, so that's going to be plus 8. When I'm saying height, it is the perpendicular height, this height here, not the root 20. So that is going to be a 4, and then divided by 2. So I am going to get 13 times 4 divided by 2. So basically 13 times 2, which is 26 meters squared. That's going to be my area. Now for the perimeter, I have everything except I do not have the other side here. It doesn't say that this is a isosceles trapezoid. So what I know is if this is 5, okay, because of above, if I was to go backwards to find this distance right here, I'm just going to call this x. I know that x squared plus 4 squared gave me my root 20 squared. So x squared plus 16 equals 20. So x squared is equal to 4. So x is going to be 2. So this right here is a 2. Since it's 8 all the way across, that means this is a 1. Okay, so now when I'm trying to find, let's just say I call this y, I know that that's 4. So again, I'm going to use Pythagorean, and I'm going to go 1 squared plus 4 squared equals y squared. So I get a 1 plus 16, which is going to be a 17. So my y is going to be the square root of 17. So this right here is going to be the square root of 17. So then when I'm trying to find my perimeter, I'm going to add up. So I'm going to have my 5 plus 8, which is a 13, plus a root 20, plus a root 17. And you can just leave it like that. Down the road, we're going to be cleaning up the root 20, but for right now, I'll be fine with us leaving it like that. And this would be, this whole thing is in meters. On number 10, we're making a complete graph of both of these. So let's say I'm doing this one in blue. This is a line. My y-intercept is 3. My slope is 2, so I'm going to go up 2 over 1, up 2 over 1. Let me just get that graph. And I'm going to connect it with a line. I'm going to make it a little see-through so we can see the original point. Okay, so that's that line. And then I'm going to do the other one. Let's say I do that line in red. So I'm going to start at 1. My slope is, well, it's x, so my slope is 1. So I'm going to go up 1 over 1, up 1 over 1. Actually, they cross right there. I'm going to connect these points with a line. And they want the point of intersection. And the point of intersection is where the two graphs cross, which is going to be right here at -2, -1. So -2, -1 is the point of intersection. It's where the two graphs cross. On 2-11, Missy's building a triangular planting bed. 2 of the sides have the lengths of 8 feet and 5 feet. What are the possible lengths of the third side? Okay, so let me just get a triangle here. Okay, I'm just going to kind of adjust this. Okay, so one side is 8 and one side is, let's say, 5. Okay, what can this side be? So what you're going to do is you're going to take the two sides, add them, which is 13. You're going to take the two sides and subtract them, which is 3. And that x has to be in between their difference and their sum. Any number between 3 and 13, not including 3, not including 13. That's the triangle inequality theorem. And that's the end of this video.